Okay, so we talked about how for 8a, we're really talking about we don't want to divide by 0. That is what restricts the domain of our rational function because we don't want to divide by 0. The other thing that might happen, the thing that might happen when we divide by 0 is we might get a vertical asymptote, which breaks the graph. So a vertical asymptote is going to make the graph do funky things. So here we have a vertical asymptote at x equals -3. That's a vertical asymptote. And then we also have a pole, which is otherwise known as a discontinuity, where x is 2. Okay, so that's 2 comma something. Technically, it is 2 comma undefined, but the point would be something else. We'll talk about how to do that in a moment. And so these are the things that happen that you get from your denominator, because we can see that from the denominator, x minus 2 cannot be 0, and x plus 3 cannot be 0. And so I know that x cannot be 2, and I know that x cannot be -3. So right away, for the domain, I can say the domain is x such that x is not equal to -3 or 2. It cannot be -3, it cannot be 2. But you might notice that I have the same factor here and here. What that gives me is that at 2, I don't have a vertical asymptote. I actually have this discontinuity right here, and it's shown as an open dot. I know the graph is small, but it's shown as an open dot on the graph on my paper. Desmos will actually not show it to you, but if you trace along Desmos, it'll say 2 comma undefined. So when I write the lowest terms equation, what I will do is divide these out. So I end up with 1 over x plus 3. And now what's left over, this tells me my vertical asymptote. So factors that divide out, in this case x minus 2, represent poles. And then in the LT equation, which is the lowest terms equation, factors in denominator represent vertical asymptotes. Okay, so I know that I have a VA, a vertical asymptote, at x equals -3. So when I write the vertical asymptote, I am going to identify it as an equation of a line, because that is a vertical line. So I need to write the x equals. That's really important. Okay. So when I identify the whole, I'm going to use, I know it's 2 comma something. I'm going to use the LT equation to find the y value of where the point would have been. So I'm going to say y equals 1 over x plus 3. I'm putting in a 2 for that x. So then y equals 1/5. So that is what's going right here for the y. So that is the point that is now no longer there, but the point 2 comma 1/5 is where the whole would be. Okay, so Desmos doesn't show me that, but I have to know from here that that is what happens. So please pause the video and try number 5, and then we will go over number 5. So I did the restricted domain. Now I'm going to say, hey, these are going to cross out because they're common factors. So that means that I have a hole at this one. This one gives me the hole, and this one's going to give me the vertical asymptote. So I have a hole at 3 comma something, and I have a vertical asymptote at x equals -4. I know that because my LT equation is r of x equals x plus 5 over x plus 4. So this part gives me the vertical asymptote, and then putting in, I'm just going to change this to a y, and putting in that 3 for x is going to tell me what the y value would be if that was an actual point and not a discontinuity. So 2 over 7. So that is my hole. That's my vertical asymptote, and that is my LT equation. So those are the steps you need to do to find those items. Let's scroll up and make sure we found all the items. Vertical asymptote, lowest terms equation, hole, and domain. So for this next one, I am going to say, okay, this tells me that x plus 6 cannot equal 0. So x cannot equal -6. This tells me that x plus 1 cannot equal 0. So x cannot equal -1. And then I will say that my domain is x such that x cannot equal -6 or -1. And then my lowest terms equation, it might be easier to write the lowest terms equation first. So q of x equals x squared minus x plus 1 over x plus 6. And then I will say, I'm going to put this box. Okay, so I know that this part is my vertical asymptote. It's that x equals -6. And what crossed out was that my hole is at the other undefined x. So my hole is at -1 comma something. So I'm going to try putting in y equals, and I will put -1 in for every single x. So I'm going to put -1 in for every single x. This one's a little more complicated. So -1 squared is just 1. Minus -1 becomes +1. And then -1 plus 6 is 5. So this gives me 3 over 5 for the y value of the hole or discontinuity.